Hello everyone, I am Mouliraj, Assistant Professor, Department of Computer Science and Engineering, Sri Shanmuga College of Engineering and Technology, Salem. Today we have see about the data structures graphs. What is mean by data structure? A data structure is a linear data structure and non-linear data structure. A graph is a non-linear data structure which is a collection of vertices and edges. Graphs are used to model any situation where entities or things are related to each other in pairs. The example of graph is a transposition networks. Graph definitions. A graph G is defined as an ordered set of vertices and edges, where V represent the set of vertices and E represent the edges that connect these vertices. This is the examples of vertices and edges connected the graph. Vertices V of G means A comma B comma C comma D and E. Edges of G means A comma B, B comma C, A comma D, B comma D, D comma E, C comma E. A graph can be directed or undirected. In an undirected graph, edges do not have any direction associated with them. The next one, graph definitions. Adjacent nodes, degree of node, path, length and cycle. What is mean by adjacent nodes? Vertex W is adjacent to V if and only if. Next we have C, degree of node. Degree of node U is the total number of edges incident the node U. If degree of U equals 0 means U does not belong to any edge and that node is isolated node. Next we have C about path. A path in a graph is sequence of adjacent vertices P equal to V0 to Vn such that Vi, Vi plus 1 every of E for 1 less than equal I and less than n. Next we have see about length. A length of path is the number of edges on the path which is equal to n minus 1. Next we have see about cycle. A path in which the first and last vertices are same. A simple cycle has no repeated edges or vertices. Next we have see about out degree of a node, in degree of a node, degree of a node. What is mean by out degree of node? The out degree of node U is the number of edges that originate at U. Next one, in degree of node. The in degree of node U is the number of edges that terminate at U. Next one, degree of a node. The degree of a node written as degree U is equal the sum of in degree and out degree of that node. Next we have see about representation of graphs. What is mean by representation of graph? We have see about the examples of adjacency matrix representation. What is mean by adjacency matrix? And adjacency matrix is used to represent which nodes are adjacent to one another. Two nodes are said to be adjacent if there is a edge connecting them. In a directed graph G, if node V adjacent to node U, then there is definitely an edge from U to V. That is, if V is adjacent to U, we can get from U to V by traversing one edge. For any graph G having n nodes, the adjacency matrix will have the dimension of n into n. In an adjacency matrix, the rows and columns are labeled by graph vertices. And entry Aij in the adjacency matrix will contain 1 if vertices Vi and Vj are adjacent to each other. If the nodes are not adjacent, Aij will be set to 0. This is the example diagram of directed graph. Directed graph means the A node is connected with arrow marks to the next node. Next node are neighbor nodes. Aij equal to 0 to 1 if V is adjacent to Vj, otherwise the example of directed graph we have noted the A, B, C, D, E. Okay, the 5 rows and 5 columns. The A node is directed to B and D. B and D means we have put the B and D 1. Remaining nodes are zeros. A is directed to B, so we have A comma B 1 and A comma D equal to 1. The remaining nodes are zeros. We have moved to the next node B. B is what are the node visited B? B is directed to D only, the one node is visited. So B comma D is 1, the remaining nodes are zeros. We have seen the pictures. B comma D is 1, remaining nodes are zeros. 0 means the node is not traversal. Only one node is traverse in the time. The next we have move to C. C means C is directed to B. uh, so we have C comma B is 1, the remaining nodes are zeros. Next we have moved to D. D is directed to E node only. So D comma E is 1, remaining nodes are zeros. Next we have moved to E. E is directed to C. So E comma C is 1, remaining nodes are zeros. So we have directed to A is directed to B and D. B is directed to D. C is directed to B. Then D is directed to E. E is directed to C. These nodes are we have represent 1. The remaining nodes are zeros. This is the example of matrix. Matrix means 5 into 5. We have put the rows 5 and columns 5s. So nodes presented means we have put the 1, remaining nodes are zeros. We have next topic, undirected graph. Undirected graph means we have not we have not put the arrow marks in any nodes. We have only connected the nodes vertices and edges as connected the graph. This is the matrix for undirected graph. We have also put the 5 rows and 5 columns. A is directed to, this is not directed any nodes within the arrow mark. We have not put the arrow marks. So we have any directions we have choose, and traversal we have made. So A is traverse to B and D. So we have we have put the A comma B1 and A comma D1. Remaining nodes are zeros. Next we have move to B. B means B is directed to A, C and D. So we have put the 1, B comma A1, B comma C1, B comma D1. The remaining two nodes, A, B comma B0, B comma E0. The next C. C means C is directed to E. C, what are the nodes directed? C is directed to E, B. So C comma B1, C comma E1. Remaining nodes C comma A is 0, C comma C 0, C comma D 0. So we have two nodes represented in this matrix. So we have put the two nodes 1. Next we have move to D. D is directed to A, B, E. Okay, ma? D directed to A means 1. D directed to B means 1. D directed to E means 1. The remaining two nodes are zeros. What are the nodes? D comma C is 0 and D comma D is 0. Next we have moved to E. E means E comma A is 0, E comma B is 0, E comma C is 1, E comma D is 1, E comma E is 0. So we have what are the nodes we have traversed the neighbor nodes. We have put the 1. A neighbor is D comma B, and B neighbor is A, C, D. C neighbor is B and E. D neighbor is A, B and A, B and E. What are the neighbor nodes presented? We have put the 1. The remaining nodes are zeros. Next we have moved the topic adjacency list representation. In adjacency list representation of graph, for each vertex, keep a list for all adjacent vertices. All adjacent vertices means A is the node. A adjacent nodes means B comma D. B comma D means we have represent the list. We have previous topic is matrix representation. This is the list representation. This is the example of list representation. We have put the 4 nodes A, B, C, D. So we have what are the A adjacency nodes? A adjacency nodes means B and D. So A is linked to B. Next we have A linked to D. So A comma B, sorry, A directed to B, B directed to D. The last node is null. This is the linked list structure. The diagram that follow the linked. This is the node. This is the address of the next node. Next we have move to B. B is directed to C and D. C and D. The B is directed to C and C is directed to D. The last node is null. Next we have moved to C. C is directed to D. D node only. C is directed to D node only. Last node is null. Next we have moved to the D nodes. D nodes is directed to A. D node is directed to A and B. D node is directed to A and B. The diagram is some data is changed, so we have not confused. We have A, B, D, E. So these four nodes we have applied. The diagram is A, B, D, E used, but the list representation A, B, C, D used. So we have made the these diagrams. The next advantages: it is easy to follow and clearly shows the adjacent nodes of particular node. It is used for storing graphs that have a small to moderate number of edges. Adding new nodes in G is easy to straightforward when a graph is represented using adjacency list. Adding new node in adjacency matrix is a difficult task as the size of matrix needs to be changed and existing nodes may have to be recorded. Next one, types of graphs. Types of graphs means undirected graph, directed graph, weighted graphs. What is mean by undirected graph? An undirected graph is a graph G equal to vertices and edges with the property that its edges have no directions. These edges are bidirectional in an undirected graph with edges, vertices, undirected graph with edges v comma w. W is the adjacent to v and v is adjacent to w. This is the example diagram of undirected graph. Undirected graph means no directions mentioned or followed in this graph. We have bidirectional graph. This is the example diagram of undirected graph. We have moved to next topic, directed graph. What is mean by directed graph? A directed graph is a graph G equal to vertices and edges. Write the property that is edges have directions and edge E comma Vi Vj means that there is no arrow whose head is pointing to Vj and the tail to Vi. A directed graph is also called a DI graph. This is the directed graph. A directed graph means we have make the directions A directed to B, A directed to D, B directed to D, and D directed to E, E directed to C, C directed to B. We have put the arrow marks in the graph. This is the example of directed graph. Next we have see about the undirected graph. What is mean by undirected graph? In a directed graph, if some positive non-zeros integer values are assigned to each and every edges, then it is known as weighted graph, also called as network. This is the example of weighted graph. Weighted graph means the nodes are v1, v2, v3, v4, v5, v6, v7. v1 connected to v2, the weight is 2. Next v2 is connected to v5, the weight is 10. Next v2 connected to v4, the weight is 3. v1 connected to v4, the weight is 1. v1 connected to v3, the weight is 4. The connected some values in between the two nodes, this is the weight. This diagram is also called a network. This is the weighted graph, example of weighted graph diagram. Next, strongly connected graph. What is mean by strongly connected graph? A directed graph is called strongly connected if there is a path from every vertex to every other vertex. This is the 1, 2, 3 and 4. This is the directed graph, is also called as a strongly connected graph. Next one, weakly connected graph. What is mean by weakly connected graph? If a directed graph is not strongly connected but the underlying graph without directions to the arcs is connected, then the graph is said to be a weakly connected. This is the example diagram of weakly connected graph. Next one, completed graph. A complete graph is a graph in which there is an edge between every pair of vertices. A complete graph with n vertices have n minus 1 divided by 2 edges. This is the